Continuing with our chapter States of Matter. In that, we are continuing with our chapter Gaseous State. Okay. So, in the previous class, we discussed about Boyle's law and Charles' law. Okay. So, in today's class, we will continue with the next law, which is called Gay-Lussac's law of pressure temperature relationship. So Gay-Lussac's law. Okay. So this Gay-Lussac's law, it gives the relationship between pressure and temperature. It gives the relationship between pressure and temperature. So what is that law? Okay. So here pressure and temperature relationship, so volume will be constant. Okay. So at constant volume, the pressure of the gas, okay. So pressure of fixed mass of gas is directly proportional to is directly proportional to its temperature, is directly proportional to its temperature. So how we can write? So pressure is directly proportional to temperature. So P is directly proportional to T at constant volume. Okay, at constant volume. So if I want to remove this proportionality, I will add a constant K. So P is equal to KT, or I can write it as P by T is equal to a constant. So this is only Gay-Lussac's law. Okay. Now suppose if it is for more gases, what it is, if it is for different pressures and different temperatures, then I can write it as P1 by T1 is equal to P2 by T2 is equal to P3 by T3. It will go on, so everything will be equal to a constant. Okay. The fourth one is called Avogadro's law or Avogadro's hypothesis. Avogadro's law or Avogadro's hypothesis. Avogadro's law or Avogadro's hypothesis. Okay. So what is Avogadro's law or Avogadro's hypothesis? It gives the relationship between volume of a gas and number of moles of the gas. It gives the relationship between volume of a gas and number of moles of a gas. Okay. So what is that law? Equal volumes of all gases. Okay, equal volumes of all gases under same temperature and pressure. Under same temperature and pressure contains equal number of moles. So this is Avogadro's law. First I will explain this law. So suppose I am taking 3 containers. Okay. So all the 3 containers are having the same volume. This is also 5 ml, this is also 5 ml, and this is also 5 ml. Okay. So in this I am taking hydrogen gas. In this I am taking oxygen gas. In this I am taking nitrogen gas. Okay, so the volume is same. Okay, height 5 ml, 5 ml, 5 ml. The volume is same, but the gases are different. So I am going to maintain all the three containers under same temperature and same pressure. So if the volume is equal and if the pressure is same and if the temperature is same, if all the three are same, okay, then even though if the gases are different, then their number of moles also will be same. The number of moles also will be same. So that is only called as Avogadro's law. Now you read the law. Equal volume of all gases. Equal volume of all the gases. Same temperature and pressure. Then they will contain equal number of moles. Okay, so this is Avogadro's law. So how we can represent this law? Volume is directly proportional to number of moles they have given. So I can write it as V is proportional to N. So V is equal to Kn. For removing proportionality I am adding a constant. So or I can write V by N is equal to a constant. Suppose if there are two different volumes and two different number of moles, how I will write? V1 by N1 is equal to V2 by N2. It will go on, it will be equal to a constant. Okay. The next one is ideal gas equation. Ideal gas equation. Ideal gas is a equation is a very important question. First, I will say what is meant by a ideal gas. So we have studied different laws: Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law. So if the gas obeys all the gas laws, then we will call that gas as an ideal gas. So ideal gas means the gas that obeys all the gas laws. It is called as ideal gas. So now we are going to derive an equation for ideal gas. So first, what does the Boyle's law say? According to Boyle's law, we know V is inversely proportional to pressure. Okay, then according to Charles' law, what is Charles' law? V is directly proportional to temperature. And what is Avogadro's law? Avogadro's law states that V is proportional to N. So all the sides I am taking V in the left hand side, and whatever it is, that law, that I am writing. Okay. So now I am going to combine this Boyle's law, Charles' law, and Avogadro's law. So I am going to combine. Okay. So combining all the three laws. Combining all the three laws, what I will be getting? So I will be getting V is proportional to 1 by P into T into N. Okay, so I will be getting V is proportional to N T by P. Like this I will be getting. So to remove this proportionality sign, I am going to add one constant R. So V is equal to R into N into T divided by P. R is a constant. The name of the R is a gas constant. Okay, gas constant. So if I'm going to rearrange this P, I am bringing this side. So I will be getting PV is equal to nRT. So this is the ideal gas equation. Very simple, right? So this is the ideal gas equation. So from this, how we can calculate the value of R? So if they ask ideal gas equation, you can write till this. Okay. So how to find out the value of the gas constant? From the ideal gas equation, you will get R is equal to PV divided by NT. Okay, PV divided by NT. So I am going to consider the ideal conditions. Ideal conditions means pressure. I am going to take it as 1 atmosphere. What is the normal ideal volume? Ideal volume is 22.4 liters. Number of moles I am going to take it as 1, and temperature I am going to take it as 273 Kelvin. So if I substitute all these values here, I will get the value of R. So if I substitute all the values, so R is equal to 1 into 22.4 divided by 1 into 273. So I will be getting R is equal to 0.0821. So pressure unit is atmosphere, volume unit is liters, or I can write decimeter cube. That is also the unit for volume. Okay, then for N it is moles. So if the moles comes to the numerator, it will become mole inverse, and 273 means it is Kelvin. So if that comes to the numerator, it is Kelvin inverse. So the value of R is 0.0821 atmosphere, decimeter cube, mole inverse, Kelvin inverse. This is the value of R. It is a very important 1 mark question. Okay. Now we studied that R is equal to PV divided by NT. So this pressure is having different units. What are the different units of pressure? Atmosphere. Okay. Atmosphere is one unit. Okay. Then Pascal is there. This is one unit. Okay. And bar. This is also one unit for pressure. Similarly, if you take volume, volume can be in liters, decimeter cube, meter cube. Yes or no? Many units are there. So when I substitute each unit, I will be getting a different value for R. Okay, different value for R. So what are the different values of R? Okay, you must have a note of it. Okay, so already we found out one value. What is that? R is equal to 0.0821 decimeter cube, atmosphere, mole inverse, Kelvin inverse. So what are the different other values of R? So take down R is equal to 8.314 Pascal, meter cube, Kelvin inverse, mole inverse. So here pressure is in terms of Pascal and volume is in terms of meter cube. So R is equal to 8.314 into 10 power minus 5 bar meter cube Kelvin inverse mole inverse. Here pressure is in terms of bar. So R is equal to 8.314 into 10 power minus 2 bar decimeter cube Kelvin inverse mole inverse. So here pressure in terms of bar and volume in terms of decimeter cube. So another value is 8.314 into 10 power minus 2 bar liters Kelvin inverse mole inverse. Here volume is in terms of liters. And another one, R is equal to 8.314 joules Kelvin inverse mole inverse. Okay, so joules means in terms of energy we are writing the value of R. Okay, so understood. So these are the different values of R. So we have completed the laws, gas laws, and ideal gas equation we have derived, and we have found out the different values of R also. Now the next one is Dalton's law of partial pressures. Dalton's law of partial pressures. So what do you mean by Dalton's law of partial pressure? Suppose if I am taking a container. So in this container, I am having gas number 1, gas number 2, gas number 3. Three types of gases I am having inside this container. Suppose if I want to find out the total pressure of this container, total pressure which is present inside this container. You know, if the gas is present inside the container, it will give pressure to the walls of the container. Already in 9th standard you have studied a gas exerts pressure on the walls of the container. Suppose if I want to find out the total pressure inside this container, what I should do? I should find out how much pressure this first gas is giving, how much pressure the second gas is giving, and how much pressure the third gas is giving, and I have to add all these things. Okay, so that is only called as Dalton's law of partial pressures. The total pressure of the system is equal to the sum of the addition of all the partial pressures of the gases. Okay, so write down the law. The total pressure of a mixture of gases, total pressure of the mixture of gases is equal to the sum of partial pressures of each gas present in the mixture. Each gas present in the mixture. Okay. Suppose if I consider a mixture containing 3 gases. A mixture containing 3 gases. So what will be the total pressure of this mixture? It will be equal to partial pressure of the first gas plus partial pressure of the second gas plus partial pressure of the third gas. Okay. So now you know the relation ideal gas equation. So what is ideal gas equation? Ideal gas equation is PV is equal to nRT. Yes or no? From this, what is P value? P is equal to nRT divided by V. nRT divided by V. So this one I can write for this individual gases. So for the first gas, I will be writing P1 is equal to N1. N1 means number of moles of the first gas. R is a constant, T is the temperature. All the 3 gases are under the same mixture. So they will be having same temperature and in the same container. So volume also will be same. So P1 is equal to N1 RT divided by V. Similarly, P2 will be equal to N2 RT by V and P3 will be equal to N3 RT by V. N3 RT by V. Okay, so now I have to substitute the P1 value here, P2 value here and P3 value here. So what I will be getting as total pressure. So I am substituting here P total is equal to, instead of P1 I am substituting N1 RT by V, plus instead of P2 I am substituting N2 RT by V, instead of P3 I am substituting N3 RT by V. So P total will be equal to RT by V, I can take it as common, N1 plus N2 plus N3. So P total is equal to RT by V into N total, total number of moles. Okay, so this is the partial pressure of Dalton's law of partial pressure. So all these three are constants. Yes or no? So how I can write? I can write P, this N, if I bring this side, it will become divided by N is equal to, this is constant. So I can write P by N is equal to a constant. Or for different pressures and number of moles, I can write P1 by N1 is equal to P2 by N2 is equal to a constant. So like this I can write. Okay. So now I am again taking this expression. So total and all I am not writing. So I am taking this expression again. Okay. So P is equal to RT by V into N I am getting. Okay. So if I bring this N this side, what I will get? Pn is equal to RT by V. Okay, so this is nothing but PV is equal to nRT, ideal gas equation. Yes or no? So I can write it as Pi divided by Ni is equal to RT by V. Pi is divided by Ni is equal to RT by V. So instead of RT by V, I can substitute Pi divided by Ni. So substitute this value in this equation again. Okay, substitute this value in this equation again. So what I will be getting? So I have P total is equal to, instead of RT by V, I am going to substitute Pi divided by Ni. So Pi divided by Ni into N total. So I will be getting like this. Okay, so or I can write P total is equal to N total divided by Ni. I'm rearranging into Pi. Like this I can write. Okay, I'm just rearranging. Okay, suppose mole fraction. You have studied the formula for mole fraction. Okay, so what is the formula for mole fraction? Mole fraction, in first lesson you have studied. Mole fraction, the symbol is X. Okay, so mole fraction symbol is X. Mole fraction is equal to number of moles of the gas divided by total number of moles. Number of moles of the gas divided by total number of moles. That is the formula for mole fraction. Now I am going to rearrange this equation. I am going to bring this Ni this side and N total to the denominator. So what I will be getting? P total into Ni. Okay, this N total, if it comes this side, it will come to the new denominator. N total is equal to Pi. Okay, so Pi is equal to P total into, what is this Ni divided by N total? Ni is number of moles and N total is total number of moles. So I can write this in terms of X. So instead of this, I'm going to write it as mole fraction X. So Pi is equal to Xi into P total. Xi into P total. Okay. Suppose I want to find out the partial pressure of the first gas, then I will be writing it as P1 is equal to X1 into P total. Okay. For second gas, P2 is equal to X2 into P total. So like this I will be finding. Okay. So understood what is Dalton's law of partial pressures? Clear? Yes.